Hi!
What do you want?
Nothing. Are you okay?
Why wouldn't I
You seem upset.
be? So,
Well,
what?
I was wondering
If?
if you want to hang out with me.
Sure.
Oh, great!
And they live happily ever after. So all elements on the table are unstable, unlike group 18, and that's because they have a full valence shell. As you can see, helium has 2, neon has 8, and so on and so forth. Now, when elements try to become stable to manipulate elements in group 18, they either gain or lose electrons. For instance, fluorine has an electron configuration of 2,7, so it gains an electron to have an electron configuration of 2,8. In this process, it manipulates neon. Lithium has an electron configuration of 2,1, so it loses 1 electron to be stable, and its electron configuration manipulates helium. Now, and when this happens, fluorine attracts to lithium because fluorine becomes negative 1. That's ugly. And lithium becomes positive 1. And since positives and negative attract,
You will see bonding on this board, nonpolar and polar, the 2 types of covalent bonding. But specifically, when 2 negatives come together, they repel, causing a repulsion, and the same thing holds true for 2 positives. In nonpolar covalent bonding, there's basically equal sharing. Polar means unequal, non means not. So, not an equal sharing. But in a polar covalent bond, there is an equal sharing due to the electronegativity difference that exists between the 2 atoms. In ionic bonding, there is a positive side and a negative side, which results in a transferring of electrons from one element or atom to the next, creating 2 ions because they're both with different number of electrons.
Student set to make models. In this sheet, we have demonstrations of what color represents what element. So I will show you a demonstration of water, aka H2O. So for that, I would need hydrogen, 2 of them. I would need a red oxygen. In order to connect it, I would use 2 medium-sized sticks. I would connect them together. Now, my friends, this is a demonstration of water. Now I'm going to show you a demonstration of ammonia. For that, I would need blue, which is nitrogen, 1 nitrogen, and 3 bottles of hydrogen. 1, 2, 3. I'll have to connect them as well with the inside sticks. So I'm going to start off by putting the sticks inside. I'll connect them to 3 poles. 1, 2, 3. And that is a demonstration of ammonia. Okay, so for my final demonstration, I will be making carbon dioxide. In order for that, I would need a flag. 1, which represents carbon. And for the dioxide, I would need 2 demonstrations of oxygen. For this one, I would be using smaller sticks, which look like these. Connect them to the carbon. As well as to the oxygen. That is carbon dioxide. This will be all for today.
Bond is called attraction.
Oh my god.
Excuse me? Is there something funny?
You're
What don't you understand?
any of it. All of it. Yeah.
Oh, that's easy. Here's what you're supposed to know if you go for your quiz tomorrow. Dispersion forces will causes them to occur while pressure on a large nonpolar molecules causes electrons to shift. So you also know that these are the final and weaker intermolecular forces, okay? So what causes them to shift, you can see in this diagram. On this side, it's slightly negative. Tell me why.
Because it wants to.
Oh, is it because it's giving away an electron? Is that why? Oh, it's receiving one.
You can see on this that there are mostly negatives on this side. So this side would be slightly negative. So there's a positive nucleus right there in the middle. So this side would be slightly positive. And what causes them to attract is that this side, since it's slightly negative and this is slightly positive, will cause an attraction over here because opposites.
Right.
Oh yeah, that's true. And remember, they do not have a bond. Their bond is called an attraction.